Hello, everyone. Again, this is Tuseme Fortunate Agnes, a student at Makerere University, and I'm in my second year, the first semester. So I've come back again. Again, we're here to share about how AI, that's artificial intelligence, how can we use it to solve the problems around us? And in particular, I looked at traffic lights. How best can we solve the problem of traffic jam using artificial intelligence through traffic lights? So again, we're going to talk about what traffic lights are, how they operate, what are they basically, when you hear of traffic lights, what comes into your mind? So basically, they are a set of automatically operated lights that commonly, these are the common colors, they commonly appear in green, amber, and red, and they communicate differently. These different colors communicate differently. For example, green communicates go amber, green communicates go red, stop. Okay, they communicate different stuff. So using artificial intelligence, wherever you come across AI that is artificial intelligence. So using artificial intelligence, my aim is to control the flow of vehicles in different lanes, just to make sure no lane is released without a single vehicle, because that would lead to wastage of time and resources. Then the other objective is to make these traffic lights group different vehicles in different lanes depending on their weights, on their heights and widths, and also um grouping them depending on what they are carrying. Are they transporting goods? Are they transporting people? Of course, cargo vessel type of vehicles are always huge and they require big space. And so it would be very good if we actually split them from vehicles transporting human beings. It actually, besides that, we all know that cargo type of vehicles, these vehicles that transport goods, they normally have a low stability rate. And in most cases, due to the fact that their stability is low, they normally face accidents. Yeah, they normally turn over. Which one should I use? They're involved in so many accidents due to the fact that they are heavy, their stability is low. So the fact that they have a low stability rate, it would be best if we separated them from vehicles transporting human beings, just for the safety of people's lives. So now we're talking about AI environments. So in AI, we also have environments, and an environment in AI is the surrounding of the agent. The agent takes in input from the environment through the sensor and delivers output to the environment through actuators. And when you look at traffic lights, some of my environment are cars, people, and roads. You get them? Because this is what the agents detect before traffic lights release or maybe stop people or maybe alert people to get ready. They're supposed to have taken in some information. For them to make a decision, they have input they are depending on to give an output. I hope I'm very clear about that. Yes, we have agents like I told you, and an agent in artificial intelligence is an independent program or entity that interacts with its environment by perceiving its surrounding through sensors, then acting through actuators or effectors. For example, like I told you in my project of traffic lights, like I said before, in my environment, we had things like people, we had cars, and what else did we have? People, cars, and let me see, and the road itself. So the agent is actually part of the system. It could be software, we could be having human agents, we could be having software agents, but in traffic lights, we majoring in software agents. For example, like I remember in the first place, I think that was the very first presentation, I told you how traffic lights operate, and I told you an inductive coil is placed in the ground and it acts like a magnet, and every time a car stops over it, there is change in the magnetic field due to an interaction, because car is made of metal. So metal and maybe the magnet, of course, there would be an interaction, and this will change the magnetic field. And so every time the magnetic field changes, then this change is communicated to the traffic lights through wires, and that is a point at which the traffic lights maybe release the vehicles. So I'm bringing all that about just to relate it to AI agents, and of course one of my agents is the inductive loop that acts as a magnet, and the other are the wires that detect the change in the magnetic field and inform the traffic lights. I hope that is very clear. Then moving on, like we did previously, we talked about our data set, and it's still the same data set, the traffic light detection data set. It has not changed because you're still working on the same project. This data set is based on CCF BDCI and is used for traffic light prediction. This dataset contains 2,600 officially labeled traffic light categories and color labels. The traffic light category includes, this traffic light category includes 9 categories. Among which are lane lights, direction indicator light, flashing warning light, and the rest. Then informed search. This is now informed search, and this algorithm of uninformed search contains information regarding the goal set. Like before you, in the very first place, there is information already stored in the maybe database or somewhere, but it doesn't begin from scratch. It already has information to depend on in order to make a decision. So in relation to traffic lights, the available information to be built on during decision making is maybe the stored records of how busy or redundant a road has been the past times, or the type of vehicles that usually use the road. We also have uninformed search. Uninformed search is actually the opposite of informed search. For uninformed search, everything is built from scratch. You look for information on your own. There is nothing you do. And so in relation to traffic lights, vehicles are detected due to the change in magnetic field that comes about each time a vehicle stops over the inductive coil placed in the ground. People, I've talked about this several times. I believe you guys understand it. Then, as I conclude, we're going to conclude with AI accountability. In AI accountability, you have to be so very specific enough and tell people out there what your program does. Because in case it doesn't fulfill what people thought or what people misinterpreted, it could maybe get you sued, or it would get you in trouble. So basically, AI accountability, my project of traffic lights has to ensure that no lane is released yet it has no single vehicle in it, because that would lead to wastage of time and resources. The other thing is for it to ensure, for the traffic lights, they're supposed to ensure that it is able, they're supposed to ensure that they are able to detect and separate cargo vessel vehicles. Cargo vessel type of vehicles from vehicles transporting human beings. Thank you for listening. I am Tusime Fortunate Agnes. And please like, subscribe, and enjoy my stuff. Thank you so much.